So we are continuing this key idea from this unit about radian measure. So yesterday the big focus was we spent a lot of time just get wrapping our brains around how to create this tool that will help us to determine values for the special angles of the exact trig ratio values for special angles. So we filled this in and we stated the values for when the angle was 0, pi over 2, pi, and 3 pi over 2, and for the quadrant 1 angles. And then the idea here is if you know how to find if you know this quadrant and you know cast rule, you guys get that you can figure out the exact value for any trig ratio for any special angle, not just quadrant 1, but anywhere on the unit circle. Because the whole idea of what the unit circle does is it allows you to figure out for multiples of the special angles what the values of the trig ratio are, and they're always going to be related to the acute angle. I'll just refresh your memory for a little bit. So let's say I wanted to figure out this angle here. So don't have to write this, just think about this for a second. I know that the angle here is 2 pi over 3. If I drop a perpendicular here, right, obviously I've created a triangle over here, okay, outline it in purple triangle over here, okay, and that purple triangle, 2 pi over 3 is not inside that triangle, but right there is an angle inside the triangle that's related to 2 pi over 3. Do you remember what we called the angle, the acute angle inside the triangle formed? Related acute angle. Do we agree that that's an acute angle in there? And if you were in Mr. Tran's class, you called it beta. If you were in my class, I kind of went RAA, related acute angle, RAA. Okay? And the idea here is if you use that reference to do sine, cos, tan, you know what I mean? You can figure out the values for 2 pi for sine, cos, tan of 2 pi over 3. But you actually don't even have to do that anymore. The whole point is you have this point here that tells you what sine of 2 pi over 3 is, cos of 2 pi over 3 is, and you have a strategy of finding what tan of 2 pi over 3 is. It's related to this point because aren't those 2 points pretty much the same except for the fact that there's a sign difference, SIGN, right? The only difference is because of the cast rule. So if I use cast rule and the knowledge of the unit circle, specifically quadrant 1, I'd be able to figure out any exact trig ratio without needing to touch the calculator. That's the key. You don't want the calculator to be your crutch because, again, I keep saying it over and over again. AP exam, they might ask you what sine of 2 pi over 3 is. You can't use your calculator to check. You have to know it. Okay? And that's where we're going with this. So all multiples of the special angles will have the same values for the trig ratios with only the sign changing depending on which quadrant the angle is in. So here's a typical example of a question where I have a whole bunch of trig ratios here. State the exact value of each trig ratio. You should not have to touch your calculator for this. Every angle here is a multiple of either pi over 6, pi over 4, or pi over 3. And you could say, well, pi over 3 is also a multiple of pi over 6, but I want you to kind of keep in mind those locations. Pi over 6, pi over 4, pi over 3. Do you guys get that anywhere else in the other quadrant, it's going to be a mirror image of one of those 3 locations. And it's going to be a congruent triangle to one of these 3 triangles. You see what I'm getting at? So if I want to do this question, you guys on the previous page, you should have the unit circle fully labeled right there to refer to. I don't have it, so I'm going to do like a little mini version of the unit circle right here. And honestly, this is really all you need to do unit circle questions. Okay? To do questions like this. Okay? I know that in this quadrant we've got pi over 4, which corresponds to root 2 over 2, root 2 over 2. I also have, okay, pi over 6. Do you remember what that point corresponded to over there, guys? Root 3 over 2, comma, half. And then we've got pi over 3 corresponding to half root 3 over 2. Okay. I could also label like 1, 0, 0, 1, negative 1, 0, 0, negative 1. But if I look at all these angles, you guys notice, look at the denominators. 3, 4, 6, 3, 4, 3, 6, 4. They're all going to be related to these ones because of the denominator. If it was going to be on an axis, you guys get there would be a 2's in the denominator. Am I making sense? Okay? So the idea here is, if I know this, and I know this rule, I can find these without any work, without touching my calculator. It's just using the tool that I have at my disposal. So sine of 5 pi over 4. Here's your thought process. I need to figure out what quadrant 5 pi over 4 is in. Can we do that? So if pi over 4 is here, where will 5 pi over 4 show up? Do the counting rule that we talked about yesterday, right? Pi over 4, remember the axis is 2 pi over 4. In this quadrant, I'd be at 3 pi over 4. Over here, I'd be at 4 pi over 4 pi. 5 pi over 4, oh, I found where I want to be. I'm in quadrant 3. So I know that 5 pi over 4 lies in quadrant 3. In quadrant 3, is sign positive or negative down here? Sign is? Because what does the letter tell you of Castro? The letter tells you in that quadrant, that ratio is positive. So it's not an S, it's a T, so sign must be negative. So I already know my answer is negative. Now, what is the answer? This is where you refer to your quadrant 1. Sine 5 pi over 4, what's its related acute angle? Pi over 4. That's the nice thing, the denominators will match. So if I drew this, like, here's another way of thinking of it. If I drew in purple, okay, if I did this, and do you guys get that this angle right here, that's 5 pi over 4. Starting at the positive x-axis, I spin my terminal arm, I pass pi over 2, I pass pi, I'm a quarter or halfway through this quadrant, that's 5 pi over 4. Okay. What if I did my triangle? Do you guys get this triangle right here? Has a radius of 1, okay? Root 2 over 2 over here, and root 2 over 2 over here. But what do we notice about both of those? They'd both be negative over in this quadrant. This is making sense, okay? But here's the key. In here, is there an acute angle that matches up to the 5 pi over 4 that goes along here? What would just this piece of that angle be? It would be how much into quadrant 3 is this terminal arm? It's how would you describe this angle right here? It would be pi over 4. Okay, is there a match to that in quadrant 1? Ding ding. Okay. All you need to know is once you know what sign it is, you just go to the corresponding acute angle over here and pick the value of sine pi over 4. It will be equal to sine of 5 pi over 4. So what is sine of pi over 4? Which coordinate again is sine? The x or the y, guys?
Y.
Y. Remember y for sine. So isn't it right there? Root 2 over 2? But it's going to be negative root 2 over 2. Because I don't want to have to draw triangles everywhere. That's going to be very tedious and long. The idea is, though, if I did, from here, use this as my reference, and I did opposite over hypotenuse, do I also get negative root 2 over 2 over 1, which is negative root 2 over 2? I would get the same thing. Make sense? Okay. So let's try the next one. Tan of 2 pi over 3. So we don't need, everything I just did there, you don't have to do every time. Like this is all, that was just me showing you what's going on. Okay. We now can just do it by counting. So if I want tan of 2 pi over 3, so I know pi over 3 is in quadrant 1, where's 2 pi over 3 going to be? Matching angle over here in quadrant 2. Okay? So I'm over here, I'm in quadrant 2. In quadrant 2 is tan positive or negative?
Negative.
So I already know my answer is negative. Now I just need the corresponding value of tan for pi over 3. It will equal the value, ignoring the sign, the value will be the same. So how do I find tan again, guys? Tan theta is sine over cos, y over x, cover up the 2's, you get? Root 3 over 1 or answer. Yep.
I thought that when You're like moving around in the circle, those values like change back and forth.
So, but like there'll always be the mirror image, right?
Yeah, but wouldn't it be then root 3 over 2 and then 1 half?
So, no, over here, it's the same.
The point. Yeah.
This point here is going to be negative a half root 3 over 2.
Oh, okay.
So, if you have the full unit circle in front of you, could you have figured, without having to go back to part 1, could you have just figured out what tan of 2 pi over 3 is by looking at this point?
Yeah.
Tan of this point is this over this, it's root 3 over negative 1, negative root 3, done. Okay, but I just wanted you to relate it, I just want to show you relating it back to quadrant 1. You can always do that and then use cast rule. Does that make sense? Okay. If you want, like, again, you have you have your unit circle right next to you if you have your sheet open. You can just go right to the location, find 2 pi over 3, look at the point and do your manipulation, either pick cosine, pick sine, or calculate tan. It will give you the answer. Okay? How about cos of 11 pi over 6? So quadrant I find the cos of 11 pi over 6. 11 pi over 6 is in quadrant 4, right? You go all the way around, right? You're right here. You're pi over 6 away from going a full circle. That's 11 pi over 6. In this quadrant, what's cosine?
Positive.
Positive. So I know my answer is going to be positive. So again, I can go refer to the pi over 6 here and just figure out what cos is. The cosine here is root 3 over 2. That's the answer. But again, if you have your unit circle and you have this point labeled, it's labeled root 3 over 2 negative a half is cosine of that point, also root 3 over 2. Has the correct sign. So it's there. Making sense? Okay. Uh-oh, reciprocal. But just because it's a reciprocal doesn't mean you can't find it, because do you know how to find reciprocals of numbers? We sure do. We did it all yesterday, okay? So it just means you can go figure out the correct quadrant and then just adjust how you calculate. So you either are going to have to take take the reciprocal of tan or think of x over y, if that makes sense. So for cotan of 3 pi over 4, so what quadrant am I in if it's 3 pi over 4? So here's another way of thinking of it. So here's pi over, so if I do a full circle, here's pi over 4. Where's 3 pi over 4? 2 pi over 4. 3 pi over 4 is right there, right guys? That's my angle 3 pi over 4. Okay, I know that this coordinate over here is negative root 2 over 2, root 2 over 2. I need cotan. In this quadrant, is cotan positive or negative? It will correspond to the reciprocal. So what's the reciprocal of cotangent is tangent. What's tangent in quadrant 2?
Negative.
So what's cotangent in quadrant 2? Negative. And then I need to calculate cotangent. So either you can calculate tangent and take the reciprocal, or if tangent is sine over cosine, then cotangent will be cos over sine, and negative root 2 over root 2 is negative 1, or you use quadrant 1 and you do the same thing. You have the right sign. Okay. Bye. Okay. Let's do the next one. Cosecant of 5 pi over 3. What quadrant is that in? So again, you're picking all the red multiples, right? Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Down here. Everyone happy how I'm getting this? Okay? So I know where I am. It's a mirror image of this one. So this is the point. I see the right sign. Okay? So cosecant in this quadrant is positive or negative. Let's answer this question first. What's the reciprocal of cosecant? Sine. So I have to figure out what sign doing in this quadrant, because cosecant will do the same in terms of its positive or negative. In this quadrant, cosecant is negative. So I know my answer is going to be negative. And so then I refer back to here, and I usually do cosecant, reciprocal of sine. Where's sine again? Sine is?
Y.
That one, right? Sine is the y. But I don't write root 3 over 2. What do I need to write?
2 over root 3.
2 over root 3. But yesterday, what did we say we do with that? We rationalize it to
Root 3.
bingo. Okay. Secant of 7 pi over 6. So where's 7 pi over 6? You guys see it's like a game, like find the angle, find sine, pick the number, done, next. Let's just kind of repeat that process. So what 7 pi over 6 is in quadrant? 3, because pi, like 6 pi over 6 is here, 7 pi over 6, I'd be 1 pi over 6 into this quadrant. Make sense? So here I am. In this quadrant, is secant positive or negative?
Negative.
Good. And now, I need to figure out the corresponding, that was a horrible plan, of over here, right? Now I'm looking at this one. I need secant. Secant is the reciprocal of cosine. Here's cosine. I need the reciprocal of this. Can I write the reciprocal of this? 2 root 3 over 3. That one's the same. Okay? Is everyone seeing the process? Again, if you have the full unit circle, you don't have to go back to quadrant 1. You just pick the point and do your reciprocal at that point, or you do y over x or x over y at that point. Does that make sense? Okay? So maybe I'll do the last, I'll do the last two using the unit circle just to kind of show you how you can do it if you have the unit circle right in front of you. So the last two are a little bit different as well because we're going to have two little kind of extra pieces of information that you might have to worry about. So in G we have sine of negative 7 pi over 4. So what's different about that one than all the other angles we just looked at? Negative. Do you remember what happened last year if an angle was negative? You're talking about your unit circle. You're talking about rotation angles. Your positive x-axis is always the initial arm. If you travel, I don't know why I make it up so far. Okay. So if I want to go travel a negative angle, if I want my terminal arm to travel through a negative angle, which direction is it going to go? Hi. It got taken down, I think. Yes, yeah, thank you. Clockwise. That's the key, right? Default, positive angles go counterclockwise through the quadrants 1, 2, 3, 4, like normal. Okay? But negative angles will go clockwise. Okay? Is it making sense, everyone? So negative 7 pi over 4 is going clockwise. And if it's going negative 7 pi over 4, I'm going to go back to the full unit circle. Here it is. I start at 0, 0, or sorry, I start at 1, 0. If I go counterclockwise 7 pi over 4, sorry, I go clockwise 7 pi over 4. You guys get that this 7 pi over 4 isn't negative 7 pi over 4. If I only go this distance, what have I just traveled? Like what angle does this represent, do you think? Negative pi over 4. This is not negative 7 pi over 4. I can't just stick a negative in front of this like, done. It doesn't work like that. Where's negative 7 pi over 4 going to be? This is negative pi over 4. This is negative 2 pi over 4. Negative 3 pi over 4. Negative 4 pi over 4. Negative 5 pi over 4. Negative 6 pi over 4. Negative 7 pi over 4 is actually, I've gone this distance 7/8 of the way. Does that make sense? And so everything, so if I want sine of negative 7 pi over 4, I just need to grab the sine value of that point. Does that make sense? So that's what would happen there. So sine of negative 7 pi over 4 is root 2 over 2, positive done. Everyone cool with that? Okay. Okay, tan of 10 pi over 3. What's wrong with 10 pi over 3? That's bigger than 2 pi. But that's the power of a circle. You can keep going and going and going, right? Arc lengths, angles, we've talked about this with angular velocity, right? You can keep going around. So where would 10 pi over 3? It's still a multiple of a special angle. Where is it going to go? So if I start at, here's pi over 3. If I want to go to I don't have to start here. Like, if I make it one full circle around, how many pi over 3s did I just rotate through? 6 pi over 3. Because what's 6 pi divided by 3? 2 pi. So it's 6 pi over 3 makes me get back to the beginning. 6 pi over 3. If I still count by pi over 3s, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3. Do you guys get that this is the angle that they're telling you?
No.
That's 10 pi over 3. I go one full rotation, so I do a full circle, but then I have to keep going to get the extra amount. But the terminal arm is still the same. I don't know why I'm doing so thick today, but the terminal arm is still the same. So guess what? The same values here are going to be the same values you would get if it was 4 pi over 3. Okay? So I need, what was it, cosine? What was that asking me for? Tan of 10 pi over 3. So I look over here, can I calculate tan at this location? Tan is sine over cos, y over x, negative root 3 over negative 1, which is root 3. So do you get how it works? If you have the full unit circle at your disposal, it's actually easier than what I was showing you, because you didn't have to go back to quadrant 1, but it just means that you put the effort in to make the full unit circle to refer to. Does this make sense, everybody? Okay? So, let's do it. By the way, guys, by the end of today, I'm going to send you another PDF practice that's just a page of these to practice without a calculator. See if you can get them. Okay? You can use your unit circle, but you don't use a calculator. Yeah.
Like realistically, you can just keep going around and around and around, but you're never gonna do a question like what is 10 of like 30 pi over 3 or something like that.
35 over 3 is just 10 pi.
Well, yeah, but no, but you know what I mean? Like something like random, like really.
Well, I can definitely go bigger than 2 pi.
Yeah. No.
And then it's just kind of a matter of figuring out the pattern. You know what I mean? So I'm not gonna go crazy, but I could go for sure more than once around.
Oh yeah.
Okay. Just even think of it like just like this is thinking ahead, guys. We're gonna eventually be going to, you know, at the end of this unit, real life situations. Do you guys remember the real life situations you did with trigonometry last year? Like the
helicopter.
well, that was triangle trig, but do you remember the other type of word problems like the tide? Like the tide comes in and out, and the max tide or the deepest is here, and then the less deep, and it follows a sinusoidal motion. But I'm even going to go to this. Remember Ferris wheels?
Yeah.
So if the Ferris wheels, like I could say, a Ferris wheel revolves, you know, 10 times in, you know, 10 minutes, or 10 times in, I don't know, make up a number. 8 rotations in 10 minutes, or something like that. So now you have like do you guys see how it connects to what we were just doing, to the fact that, what if I said, at how many times was this person, you know, X meters high? Do you guys get it? Could be multiple over the whole span of the ride. They're at that height multiple times because the circle keeps going around and around and around. You don't have to stop after one spin. You can figure out what it is for multiple spins. But again, that's thinking way ahead. We're getting there by next week, not next. Okay? Cool. All right. I'm basically running through types of questions that you're going to encounter in 6.2 for the rest of this lesson. So that's one type. Here's another type. Determine the primary trigonometric ratios for negative 5 pi over 3. So just the primary. So I need you to tell me what sine of negative 5 pi over 3 is, cosine of negative 5 pi over 3, and tan of negative 5 pi over 3. Don't need, as soon as I see 5 pi over 3, calculator gone. There's no calculator happening here. This is all grabbing numbers right from the unit circle. So, where's negative 5 pi over 3 going to be? So I'm going to go back to my unit circle. Here's the unit circle. Where's negative 5 pi over 3? So first of all, as soon as you see the negative angle, what's your brain saying? I have to go clockwise. I'm counting by pi over 3s. Where am I going to hit 5 pi over 3? Quadrant. Because pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3. Yes? Okay. There it is. The point's right there. Can I just grab what sine negative 5 pi over 3 and cos 5 pi over 3 or negative 5 pi over 3 are from that point? Cosine is, or let's do sine first. Sine is root 3 over 2. Cosine is half. And tan is, you can go back to the picture or just use sine over cos is done. Okay. So, the next thing says, state an equivalent expression in terms of the related acute angle. So, related acute angle. So, I want you to understand, you have just found, you guys get the angle you've just been talking about is this one. This reflex angle going clockwise. This is the angle negative 5 pi over 3. If you take the terminal arm, drop your perpendicular, you guys get that the piece left that makes an angle with the x-axis, this angle right here, that's your related acute angle. In this case, related acute angles are always positive and less than 90 degrees, but now it's less than pi over 2. An acute angle has to be less than pi over 2. because 90 degrees is pi over 2, so less than pi over 2, less than 90 degrees acute. Okay? So, can you tell me what this green angle is? It's pi over 3, right? There it is. So what this is saying is, can you tell me I want you to, basically this is how you answer something like this. You write the ratio in terms of the acute angle, and here's the question you're going to ask yourself. Is this true right now, or do I need a negative? Here's the reason. Do we agree that the sign of acute will 100% of the time be positive? Sign of an acute angle will 100% of the time be positive for sine, cos, and tan. Because what's the deal about this quadrant, guys? What's the cast rule say? All positive. So sine of an acute angle, cosine of an acute angle, tan of an acute angle, always positive. If you're somewhere else in the unit circle, though, you could be negative or positive, depending on what quadrant. So right now, where did we say negative 5 pi over 3 was? Oh, it ended up back in quadrant 1. So is the value of sine pi over 3 exactly equal to the value of sine of negative 5 pi over 3?
Yes.
So you're done. You've stated an equivalent expression. This is equivalent to this perfectly. Okay? If I did what's cos of negative 5 pi over 3, do I need a negative, or is it exactly equal to cos of pi over 3? Here's the thing, guys. I'm referring to the exact same point, right? So will everything be the same? Yeah. So cos of pi over 3, these are true. Tan of negative 5 pi over 3 is equal to tan of pi over 3. So all of these are equivalent expressions using the related acute angle. This has to be acute for this to be true. Just to give you a sample of what might happen, what if I said, tell me an equivalent expression I'm just going to pick negative 4 pi over 3 instead. You guys get things are going to change now if I pick negative 4 pi over 3. First of all, what quadrant would I be in if it's negative 4 pi over 3? So I start over here. If I only go negative 4 pi over 3, I end up in quadrant 2. Backwards, right? Quadrant 2 backwards. Like that? So that's negative 4 pi over 3. My question to you is the related acute angle still pi over 3 here? Really? Okay, think of it like this, guys. If I only went to the axis over here, if I only went halfway around, what would the angle be? If I stopped at the axis, I'd have gone negative pi. And then to get here, isn't it an extra pi over 3? So won't this related acute angle here also be pi over 3? Right? Is it making sense? Now, here's the deal though, guys. Are sine, cos, and tan all equal to cosine, or sine, cos, and tan in this quadrant are going to all be equal to what happens in quadrant 1? Like, I'm going to write something here. I'm going to leave a little bit of a space. I'm going to write this. Right now, only one of those is correct. Because I'm equating quadrant 2 to quadrant 1. They're not equal. They're not all the same. It was easy in this one because I was equating quadrant 1 to quadrant 1. I knew everything was going to be equal. So in quadrant 2, what's the only one of these that's going to stay positive? Sine, because that's cast rule, right? Sine is positive. So this one's the true one. How do I make the other two true? You put a negative here, you put a negative here, and now you've made true statements. Because now, here's the deal. Cos of pi over 3 is a half. But what do I know cos is really here? It's negative a half. So I need to say, see this over here that's a half? I want it to equal that one. So I'm going to put a negative in front of this. Now I'm equal to that. Okay? If I'm cos of pi over 3 is root 3 over 2. Cos of pi over 3 is root 3 over 2. Okay, I think I did the wrong one here. What did I do?
Cos is X.
Yeah, cos is x. That's what I made a mistake. Yeah. So sorry, it should have been root 3 over 2, same, so I don't have to do a change. That was my bad. I read. Okay. Cosine, I have to change because cosine is negative a half and cosine over here is a half. How do I make those two equal? I have to put a negative in front of this one. Now they're equal. Okay. If I want tan, in this quadrant, tan is negative. In this quadrant, tan is positive. So in order to make them equal, I need to put a negative in front of tan in this quadrant. Then I equal the other tan. So that's what it means to state something in terms of the related acute angle. It's basically, here's the shortcut. Whatever's next to pi in the numerator, just remove it. Do you guys get it? If you do that, you're left with an angle, a special angle in quadrant 1. You remove -4, you have pi over 3. This had been negative 11 pi over 6. You just take a right of the negative 11, now it's pi over 6. The related acute angle will be in quadrant 1, and then you just have to pick the right sign. Do either the same sign or opposite, depending on where that angle is. Okay? Again, you'll get a chance to practice this in the home. Okay. The terminal arm of an angle in standard position passes through the point 6, -2. Find the radian value of the angle in the interval 0 to 2 pi to the nearest hundredth. So, now you've done this question before in grade 11, except it was with degrees, but now it's with radians. No one should be completely shocked with seeing this. Okay, interval notation for one full rotation of the unit circle is from 0 to 2 pi. Last year was from 0 to 360. Okay, so the idea here is you're told that the terminal arm passes through this point. Could I draw that point on a Cartesian plane?
Yes.
Okay, so where would that point end up? 6, -2 would be quadrant.
4.
Good. 6, -2. So here's my point, 6, -2. It's on the terminal arm of an angle in standard position. Whenever you're told angle in standard position, you don't have to worry about the negative angles anymore. Here's an angle in standard position. You start at the positive x-axis, you go counterclockwise until you hit the end of your terminal arm. So right now, that right there is your mystery angle theta. You get that the point 6, -2 is not forming a special triangle with the x-axis. This would be a non-special triangle, right? Okay, the only special triangles are when you've got the relationship 1 to root 3 or root 2 root 2 1 or 1 1 root 2. Those relationships. This one doesn't have that. It doesn't mean we can't find the angle, because the idea here is, can I come up with the value of that angle based on this picture? So you did this last year. Do you guys remember how this works? Okay, I'll give you a little bit of a hint. So it's all about looking in the triangle. This is the mystery point, like the mystery angle in here. Okay. Now my class, I called it the RAA, related acute angle. You went in Mr. Tran's class, you're going to call it beta.
Yeah, you do tan.
And so even though I care about this red angle, I'm going to focus on this angle right here as my reference. Can I come up with a trig ratio?
Yeah.
Or in this triangle that I formed, can I label the side lengths, like the legs? Across the top is
6.
and then I allowed my students, I don't know Mr. Tran, I allowed them to label this with a negative just to keep in mind that it went down. So -2. Anyone do that? Because here's the deal. If I have those two sides labeled, do I have a trig ratio that relates this reference angle to these two sides? I heard someone say it. Tangent does, right? Tangent is opposite over adjacent. Those two are numbers I know. You can pick sine, but you guys get, if you want to pick sine, now you need the hypotenuse. Now you have to find that. It's probably not going to be pretty, unless it's a perfect square, unless it's a Pythagorean triple numbers, right? So we're going to pick tan. So tan of theta is opposite over adjacent. In this case, opposite is,
-2.
and adjacent is. So tan theta is -1/3. We all agree that -1/3 is not special. You are not special, -1/3. Okay? For tan, the special numbers you're looking for are 1, root 3, or 1 over root, or 1 over 3, or root 3 over 3. Those are your nice numbers for tan that will give you nice angle exact answers. 1/3 is out, so we have to pick up the calculator now. This is like and did you kind of know you were going to have to? As soon as you see that instruction, you know that a calculator is going to be required. So I grab my calculator.
Figuring out the angle.
Yeah.
Theta or
Find the radian value of the angle. So I'm finding theta. So theta is going to be, how do I isolate for theta? What do I do with tan?
the inverse.
Yep. Tan inverse of -1/3. Now here's the first time in the course that you absolutely have to be in radian mode for this to work.
Oh, yeah.
If you're not, your calculator is going to spit out a degree answer to you. Okay? And last year you totally did it with degrees. And I think if you were in degree mode right now and you tried this, you would have gone like 18 degrees.
Yeah.
But it's not, 18 degrees isn't equal to 18 radians, you know that. Okay? So get your calculator into rad mode, and you go tan inverse of bracket -1 over 3 close bracket. The brackets are important. And I just got -0.32 approximate, because I'm rounding. This is an angle in radians. Is it theta?
No.
It's not the theta we want. It's a correct answer, but you guys get your calculator. I don't know if you remember this from last year. Your calculator will always default to the smallest angle possible. Your calculator just defaulted to that. Your calculator sped out that theta, the related acute angle theta, if that makes sense, right? So your calculator just found beta for you with a negative in front, if that makes sense. This is what I want to see if you're doing this on a test or a quiz or something. So you write that, great. So now, I want the angle in quadrant 4, like the standard position angle. So I'm going to write in quadrant 4. How do I find the theta I want? Maybe I'll label it theta 1, just to be a little clearer that theta 1 and theta aren't the same. So I want theta 1. How do I get the red angle if I know the green angle? You have to subtract. Now, last year, what did you subtract from?
360.
What are you going to subtract from this time?
2
Bingo. Make sense, everybody? You have to subtract from 2 pi. You can't mix and match with degrees and radians. You're all in with radians. Okay? 2 pi, 1 full rotation, take away 0.32, that little green angle. I get 5.96. You just found the answer in radians. We're going to put the little r, or if you prefer, you can write rad next to it. But you should, because pi isn't visible, you should make it very clear that it's a radian answer by putting the little r or writing rad. Okay? And that's how that one works. Okay? So, that's how you do a question where you're given a terminal, a point on a terminal arm, find the angle. You also, like last year, we also would make you like, state the 6 trig ratios, then find theta. Like that was a typical question in grade 11. Right now we're just focusing on the angle. But the homework might ask you to do that. If you had to do that, could you find the hypotenuse if you had to?
Yeah.
Good old Pythagorean theorem. You guys remember this version of Pythagorean theorem? Radius squared equals x squared plus y squared.
Oh yeah, that's for circles.
Yeah. Because you gotta think that that green is the length, like that green is on a unit, is on a circle, right? Like I'm just not drawing the circle part, but this is on the unit circle. Well, it's on a circle. It's not 1 unit long. So if I did this, do I have the x value?
Yep.
And I have the y value. Root 40, which you're all going to impress me by writing as. You're all going to impress me by converting this to. What perfect square goes into 40?
4 and 10.
4 times 10, and you bring the 4 out.
2.
Radius 2 root 10. Right? I just, in case this asks for in the homework, I just found the length of the hypotenuse. Okay. If you now know that, could you now tell me the exact value of sine theta? If you had to. This is just a little extra. If I said, tell me what sine theta is, okay, I guess technically theta 1 according to my picture, but sine theta would be opposite over hypotenuse. Negative 2 over 2 root 10. Could you reduce it? Could you reduce it and rationalize it? Isn't this fun? Okay. Negative 1 over, which is negative. Okay. Might show up in the homework, I'm not sure, but it might. So that's how you would find sine theta. And then you guys, if you do cos theta, you already had tan theta. And then reciprocals are easy. Once you have the originals, you can find the reciprocals by just taking reciprocals. All right, moving on. Okay, last type of question. These again should seem familiar from grade 11. Only difference, we're working in radians instead of degrees. If tan theta equals negative 7 over 24, where 0 is less than or equal to theta is less than or equal to 2 pi, evaluate theta to the nearest hundredth. So the key to this is draw a picture to help you. And then you remember that for these types of questions, there's going to be two answers. Okay? Because what this is saying is the value of tan theta is going to equal this, usually from 0 to 2 pi, because of the periodic nature of these functions, you can hit it more than once. Okay? So, for example, in this case, if I said I want you to tell me where tan theta is negative, okay, this is, in what quadrants is tan theta negative? You're going to tell me quadrants. Tan theta is negative in quadrants 2 and 4. Okay, my students will remember me doing this. The terminal arms will be in those two quadrants. I drew them on the same picture. I don't know if Mr. Tran did two different pictures. So I'm going to just draw a terminal arm, and here's the angle. Then I'm going to do a terminal arm over here, and there's the angle. Is this ringing a bell for people? Okay. There's the red angle and the purple angle. Both are correct. I need to find both answers to solve this equation. Okay? So, I have an equation. There it is. Tan theta equals negative 7 over 24. Can I find theta? Is 7 over 24 scream, I'm special. I'm going to be connected to a special angle. It doesn't. So it's going to be calculator time. Again, you can kind of tell that by the way that the question was phrased. Tan inverse, bracket, negative 7 over 24, close bracket, equals, you should get negative 0.28 approximately. Is that one of the angles I'm looking for? Are these the droids we're looking for? Okay, sorry about that. Okay. This is not the angle. What does the calculator spit out as? Remember, your calculator is going to try and pick the nicest, smallest option. What has your calculator told you? Boop. That's what your calculator decided to give you. Related acute angle negative. Because it's the only acute option. The red and the purple angles, they're not acute. Your calculator's not going to give you that. So your calculator is going to give you the acute option. It's giving you this. Can I use this to find red angle and purple angle? Because now, if you know that that's 0.28, do you guys know that's 0.28? Or if you want to call that beta, right? That's your related acute angle. Okay, just so it'll be less confusing. Yeah, if you want to label it as beta, it's fine. Okay? You guys prefer that, beta?
Yeah, because they're less.
Well, it's all about the notation, right? If you clearly label that as 1 and 2, then theta is a different symbol. So it's really your call. Okay? The betas are the same. If you want to go right now, like Therefore, beta equals 0.28, or for my students, I just kind of went RAA last year, 0.28. Either one's fine. Once you have that, can you find the theta 1 and theta 2? So theta 1 is in quadrant. The red angle is in quadrant 2. So if I want to find theta 1, how am I going to find it using my related acute angle? Good. Do you guys get that? Last year, what would you do? You would relate it to going halfway. What's halfway last year was 180 degrees. Halfway this year is pi. So pi gives you half of the circle. I need to take away the beta, take away the related acute angle. So I'm going to have pi minus 0.28. And so you're going to have pi minus 0.28, pi minus 0.28. So 2.86 radians. There's one option. And then you're going to give me my quadrant 4 option, which is theta 2. And theta 2 is going to be, look at the purple angle, guys. It's almost a what? It's almost a full circle, 2 pi. So it's a little bit less than 2 pi, so I should do 2 pi minus 0.28. If you think about this one, you don't even need a calculator for this one if you think about it. Because what's 2 pi? What's pi? Approximately 3 point. What's double?
6.28.
Minus 0.28.
I would say.
But you should still keep the decimal places. So yeah. You solved it, guys. Those are the two answers. And if you typed in tan of 2.86, you're going to get the decimal version of negative 7 over 24. And if you type in tan of 6, you would get, again, the same value of negative 7 over 24, the decimal version. But again, approximate, not exact. Any questions? Let's do that again. If cosecant theta is 5/4, where theta is between 0 and 2 pi, evaluate theta to the nearest hundredth. Oh, reciprocal ratios, boo. Maybe not so boo. Maybe we can figure out an easier equation to solve if you're catching my drift. If cosecant theta is 5/4, is there an easier version? Reciprocal. If I take the reciprocal of the left side, the reciprocal of cosecant is? So if I take the reciprocal of the left side, I also need to take the reciprocal of the right side. So 5/4 should become 4/5. Ding, ding, ding. So there it is. Solve that one. Solve the easier problem. You guys get that's a common theme, like throughout the entire course. Like, once you get something that's hard, solve the easier problem. Solve the easier equation. So there's the easier equation version of this. Okay, can I draw my little picture with sign? What quadrants are we talking this time? As sign is positive.
1 and 2.
1 and 2. 1 and 2. Everyone okay? Those are my two terminal arms for my two corresponding angles. This time, is my calculator going to be nice and friendly and actually give me one?
Yes.
Because one of my answers happens to be in quadrant 1 this time, which is acute. Everything's great. So I'm going to go theta equals sine inverse of 4/5. Again, 4/5 is not special, so we're going into decimal mode. So sine inverse of 4/5. 4/5. 0.93. You should also be trying to do this as I'm doing it. Okay, it's acute, it's positive, everything's great. I'm just going to go right in and say, I just found quadrant 1, it's 0.93 radians. So one was just found right away, I don't have to do any adjustment. There it is, quadrant theta 1, my first solution has been found. So how do I find theta 2 in quadrant 2? What's the strategy? pi minus again, pi minus 0.93. Theta pi minus related acute angle, pi minus 0.93, 2.21. Put a box, put a box. Good, good, good. Okay, solutions found. Okay, good. Now, in the two examples we've done, the one quadrant we didn't actually hit is quadrant 3. What would be the adjustment you would need to do to get to a quadrant 3, do you think? We already got quadrant 2 angle. We subtract from pi. We'd have to add the related acute angle to pi to get to quadrant 3, because you're going a little bit into quadrant 3, and so therefore you have to add the related acute angle. In quadrant 4, subtracting from 2 pi. Okay, last example from this lesson. If cos theta equals negative root 2 over 2, where 0 is less than equal to theta is less than equal to 2 pi, evaluate theta exactly.
Oh.
Why isn't there saying exactly, guys?
This is special.
Because this root 2 over 2 scream on special. Alright, here's the cool thing about this. There's literally almost, as long as you know where to look, you almost have to do no work here. Cosine theta is negative in what quadrants? 2 and 3. So I know I'm dealing with quadrants 2 and 3. Now, here's the key. It's all about recognizing root 2 over 2 corresponded to which of my special angles. The root 2 over 2 showed up.
45.
Okay, 45, but now 45 has been transformed into pi over 4. Pi over 4. Okay. Man, I wish I knew what the 2 pi over 4 multiples in these two quadrants are, because those are my answers. Right? Man, if only I had a tool that told me what these angles were, right? Like, that would be so useful. Huh? I know, right? That unit circle. Wow, so handy. Because now, all you have to do is say, as long as you recognize that it's the pi over 4 multiples, what are the 2 pi over 4 multiples in those two quadrants?
3 pi over 4. 5 pi.
Done. No calculator. Calculator. Goodbye. Didn't touch you. Didn't need it. Exact ones, you never need a calculator. Make sense? Okay. Okay. I'm going to tell you right now, guys, for the test for this unit, which isn't going to be until into next week, there will be a small portion at the very beginning that will be no calculator.
So our test is going to be on Tuesday?
No, it won't be on Tuesday.
Oh.
Won't be on Tuesday. But next week, there'll be a test. Okay? There will be, what's going to happen, like, this is how it's going to work. I'm going to give you part A, which is going to be no calculator. So no calculator on your desk. Once you hand that in to me, I give you part B. You can use your calculator for the rest of the test. But there will be, and like, so that's going to, I'm just warning you right now. Don't cheat your way through the homework here. Don't be like, look, because I know your calculators are all fancy, and some of them will even, like, you type in, like, cos inverse of negative root 2 over 2. I'm telling you, some calculator here spits out 3 pi over 4.
What do we say? What hours?
Wonderful. You have to have a super fancy one for it to do it, to be honest.
Cos inverse negative 2 pi.
Negative root 2 over 2.
Here's like root 2.
For sure, there are calculators out there that if you type in cos of 3 pi over 4, you will get the radical.
Oh, I got it.
Okay. See? Did it give you both or just one?
It gave you one.
Okay, but it gave you 3 literally with the pi in it? With the pi in it?
Yeah, like 3 pi over 4.
Okay, so
It gave me 5 pi.
so cosine's the one exception when your calculator, it can't, do you guys think there's no acute option for cosine equaling a negative? There's only obtuse or reflex option. So that's the only time that the calculator will actually give you an obtuse answer. Otherwise it goes to negative acute or acute. Okay? But the idea here is, remember, I keep saying this repeatedly, almost once a week at least. On the AP exam, guess what? Half the exam, no calculator. You need to be able to find these without the calculator. Okay? All right. So that's the official end of the of 6.2. The homework now is free reign for you to complete tonight. but I do want to start the next lesson of 6.3. 6.3, here's the good news. No homework associated with 6.3. All 6.3 is going to be doing is refreshing your memory of how to graph trig sinusoidal functions. So, flip the page, and you have to turn your page. You have to turn your page landscape style. And okay. Last year was your first introduction into graphing. The only functions you had to graph last year were the sinusoidal functions. You only had to worry about graphing y equals sine x, y equals cosine x. And then if you recall from last year, then you did transformations with those. And those are the only ones you had to worry about. So this year, we're still going to do sine and cosine. We're still going to do transformations of those two. But we're also going to graph the other four: tan x, secant x, cosecant x, cotan x. But here's the good news. You won't have to do transformations in any of those. You just have to know how to graph the parent, the main ones. Go ahead. So, how do we do it? I said you've already done this last year, so what's the difference this year? Guess what your x-axis units are going to be?
Pi.
Radians, yeah, radians. So no more degrees. Degrees are done. Okay, we want to go into radian mode. So don't write this, but do you remember last year, I hope, you remember doing something like this?
Yeah.
Okay? I want you to kind of think about this. Don't write this because this is not what we're doing this year. And then you would continue this pattern, right? Here's the reason why we want you to move into radians versus degrees. You guys think the scale here is really wonky? Like, it's a correct scale, but in terms of its relationship to the values here, just even size-wise, you guys get 360 to 1. You know what I mean? Like, it's the scale is so different. Whereas if we label this with radians, you guys get it's a little more closer to the x, like closer to the origin, if it will. In the sense that, what's the equivalent of each of these in radians? What's 90 degrees in radians?
Pi over 2.
Pi over 2. Okay. And then would come, so pi over 2 would be here. Pi would be here. 3/4 of the way was 3 pi over 2. And then I make it all the way around the circle. One cycle I made it to
2 pi.
good. You guys get 2 pi is 6.28. Do we see what I'm talking about? Like 6.28 versus like a scale around 1, 2, 3. Like it's a little more closer together as opposed to the 360. Okay? And so, plus the radians are just more, they're just easier to work with once you get into the higher level maths. Okay? So that's why we're doing it. Now, we don't just abandon our scale if you have more space, so could we continue this pattern? And label four more ticks on the scale. So what would come next after 2 pi, following this pattern?
3 pi.
So we got 3 pi over 2. 5 pi over 2. Then 6 pi over 2, which reduces to 3 pi. And then at 6 pi over 2, next would come
7.
And then 8 pi over 2, which would be 4. Okay. Okay. Now, before we label the y scale, let's look at the top. We have this little chart here. So we have from 0 to 2 pi, all the special angles that if you go around, nothing there in that first row should be unfamiliar. Isn't it literally every number there? If you went through all the boxes of the unit circle, those would be all the angles. Okay, so I want the sine value matching up with each of those angles. Man, I wish I had a tool that told me sine x for all these values. Man, I wish I knew how to do that. Oh, wait a second, that's what the circle's for. There it is. Do you guys get, look, 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, all the boxes are all those values. Man, I wish I knew where sine was in all of these. Y value, y value, y value, y value, y value, y. All the y values are your sine values. Right? So it shouldn't be a mystery that we can create this table, we can fill in this table. It's literally just pick all the y values. Okay? So let's do it. What was the first y value? Sine 0, 0. Sine of pi over 6. Good. Sine of pi over 4. Sine of pi over 3. And sine of pi over 2. You guys get, you only need that, you can fill in the rest. You don't need to go back to the circle. Because all that's going to happen now, just think of it like this. Here's the circle. You just did this. 0, half, root 2 over 2, root 3 over 2, 1. You just pick the y value of every one of these coordinates. What's going to come next, guys?
It's going to go back down.
It's going to go back down, just in reverse order, right?
Good afternoon, residents. Please pay attention to the following announcement. Thank you to everyone who auditioned for this year's school play. The cast list is posted on the door on the Cedar Arts. The first stop, Stigma Meeting for Mental Health Awareness, will be running after school today in the cafeteria. All are welcome to attend. Just a reminder for students who are writing to the receiver
But now we're going to be...
you have signed up to write in today. Please come to 303 right after school. Starting this week and throughout November, the library will be open during periods 3A and 3B. It will be closed for period 3C. The library club will meet right after school today. We are planning the SAT Winter Bazaar. It will be on Saturday, November 24th from 10 a.m. to 2 p.m. at St. Adam's Baptist Junior School. It is a big fundraiser here. It's a monthly procedure to earn the volunteer hours. They also will receive lunch. For more information, PM at home can come to us direct. There will not be a peer mission meeting today as we're going on a day trip called ACCPS. If you are going on the trip, meet at Kipling Station before 8:15 tomorrow morning. If you have not checked in with Mr. Richard yesterday, you must be on your way right after school. And now a short announcement for intramural.
Resident, it's my car show. Back at it again on the announcement. Quick announcement, just letting you know that we're taking a break tomorrow for our dog welfare event. Don't worry, we're back at it Friday for a huge tournament. Please bring your gym clothes out Friday.
Thank you for listening to the end of the day announcement, and I hope you have a great rest of your day.
Okay. And so, yay, we completed a full cycle of one cycle of the graph of y equals sine x. Man, if I had to do the next cycle, I wish I knew what the y values are going to be. Repeat, right? This is like, let's just keep going, the same values. It doesn't change. That's the whole point of a periodic function, right? So how are we going to draw this? Well, take a look. What do you notice the max and min of the y values are? 1 and -1. So just to make this easy, let's let the top square here be 1 and the bottom square here be -1, so that 4 squares is equal to 1. Which means 2 squares is equal to?
1/2.
True. Okay. Now, those of you that I taught last year, the song is coming. So the idea here is, okay, are we all happy that we can label this, put the zeros, min, max on pretty easily, right? They're all going to occur at these nicely labeled locations, right? 0, 0. Pi over 2. Pi over 2 is here. Pi over 2 is 1. Pi, 0. 3 pi over 2, -1. 2 pi, 0. Now, you can get a serviceable graph if you only use those 4 points, but I know I taught this enough times to recognize that if you don't put some more points in here, it's going to be zigzags. Okay? You just can't help it. You're either going to zigzag it, or you're going to overcompensate, and it's going to look like semicircle. It's going to be too circular. Okay? So, we're going to fill in some blanks. So, do you guys notice that I grayed out the pi over 4s? The pi over 4s we're going to ignore for the moment. Not that they're not correct, but it's like extra info you're not going to need. Plus, let's think about this. If pi over 2 is 3 grid squares, there's a reason why we chose 3 grid squares for pi over 2. Because that means 1 square is what? Pi over 6. Right? You don't have to label this every time, but you guys get pi over 6. Every square is pi over 6 if you do this. It's not just, I like 3, I'm going to make it 3. I purposely chose 3 squares as pi over 2 so that this is the relationship. That at that grid square it's pi over 6. What's going to be at that grid square? 2 pi over 6, which is?
Pi over.
You guys get that every grid square is going to correspond to every non-shaded y value, or non-shaded point. Where would pi over 4 be if you wanted to graph that one too? Right in the middle, between the pi over 6 and the pi over 3. But again, extra info, don't really need it. Hello. So to Emily?
Yes.
Okay. You want to just go with the, you want to go now, or let me do the graph and then you can, okay. So the idea here is, let's just follow the table for the moment. So at pi over 6, what's the y value? Is that easy enough based on our scale to pick? Halfway between here. So halfway. Okay. Now we're skipping the pi over 4. So now we're going to the root 3 over 2. If you type root 3 over 2 in your calculator, you're going to get this approximately. Okay. 0.866 is the approximate value of root 3 over 2. So for our purposes, is that pretty much close to 0.875?
Yeah.
Why am I thinking that number? 0.875 is 7/8. Can you visualize 7/8 of the way up? Can you visualize if here's your max, 7/8 of the way from 0 to max? If it's 4 squares, it's super easy. You just go halfway through this last square, right? That's about 7/8. Okay. You guys get that the rest of your pattern is these points, you're just going to mirror image and you're going to go down and mirror image. So, you do this, almost at the max, halfway, 0. So, let's start at the beginning, 0, halfway, almost to the max, max, almost to the max, halfway, 0. What do you think comes next? 1 square over, halfway, down. 1 square over, almost to the min, almost at the min, halfway, 0. You now have 13 points to connect instead of 5. Do you think you're pretty much guaranteed you're going to have a better shape than if you only use the 5? Okay? Oh, look, there's so much more space. Man, I wish I knew how to find these values. Guess I have to make more charts. Or do I? Can I just continue this pattern, guys? It's a fun song. Let's sing it again, okay? All halfway, almost to the max, max, almost to the max, halfway, 0, halfway, almost to the min, almost to the min, halfway, 0. Look, it took us less than like 20 seconds to do a whole other cycle. We're not like, oh my gosh, what's happening at this number? Like you're not locked into your calculator, right? That's not the point, right? Okay, so I'm going to connect this. Another, again, guiding kind of principle as you do this. You know, notice that the graph is half above and half below this horizontal line, which, if you remember, we called the sinusoidal axis. All the points above, when you connect them, they should look like they're open, like concave down. And any points below should look like it's concave up. So when you're connecting, you can sing another little song to yourself and go, sad, happy, so that it's curving the right way. Okay?
Just like in our exam.
This is like the best sinusoidal graph you've ever done in your lives. Well, yeah. It's a Bridgeford original, so you have to pay me if you want to use it.
Royalty.
Okay. Okay. Let's see what we can fill in. I want to at least fill in the first 5 here, and then maybe we'll pick up where the last 4 or last 3 tomorrow. So now we're going to take some characteristics. So, and here's the deal. So we've graphed, I'm going to use some terminology, hopefully you remember, 2 cycles or 2 periods of this function. Okay? But does this function keep going?
Yeah.
Because can't you keep going around the circle both ways, right? Like you can keep going around the circle. There's infinite angles. So there's infinite inputs, meaning infinite well, not infinite outputs, but these outputs repeated over and over and over again. So domain, x element of negative infinity to infinity, or x element reals, all real numbers are possible. We've only got the 2, like from 0 to 4 pi, but you could go beyond. You can go to 6 pi, 8 pi, 10 pi, a million pi. You can go to negative a million pi and get values. What's the range of this function, guys? Between -1 and 1. Inclusive.
Yeah.
So what type of brackets? Square, square. Equation of axis, so that balance line, y equals 0. Okay, word from last year, amplitude. Do you remember what amplitude meant?
From the length of the
From axis to top max, or from axis to bottom or to min, what's the distance? How far is it from axis to max or from axis to min? 1 unit. And then this is the one thing that's changed from last year. A period last year was 360 degrees, now a period is 2 pi. Okay? We'll leave it there for today. 6.2 homework is your responsibility to complete tonight. Please, when you look at the assigned work on the page, you'll notice some corrections I put there. Just look at that when you're taking your answers. Thank you for listening.
I just had a question. You said that the period, you did it what?
The period, it says what's the length of one cycle? Or